Hello everybody, welcome to another past paper video where today we'll be doing the AQA June 2022 Physics Paper 1. And without further ado, make sure to like and subscribe and we can jump straight in. Figure 1 shows a large wind farm off the coast of the UK. The mean power output of the wind farm is 696 megawatts, which is enough power for 580,000 homes. Calculate the mean power needed for one home, and we're meant to give our answer in watts. Well, first things first, we have to convert 696 megawatts into watts. And if you remember, mega is one step up above kilo. So it's 696 times 1,000 times 1,000, which gets us 696 million. And then for 580,000 homes, we simply divide 696 million by 580,000 and we get an answer of 120 watts. And on day one, the demand for electricity was 34,000 megawatts, and we're meant to ask to suggest two reasons why wind power was not able to meet this demand. Well, that's because wind is unreliable, so some wind turbines don't turn when the speed is too low or too strong. The reasons they don't turn for when it's too strong is because it could damage it if they allow it to turn when it is too strong. And another reason could be that there are not enough wind turbines in the UK to generate 34,000 megawatts of power. And some of the energy from the wind used to rotate a wind turbine is wasted. An engineer oils the mechanical parts of a wind turbine. Explain how oiling would affect the efficiency of the wind turbine. The efficiency would increase because the percentage of energy usefully transferred would increase. This is due to there being less work done against friction because oiling reduces the friction, so less energy is wasted. So basically, the oil or the lubricant reduces the friction, so the machine runs more smoothly and more efficiently and loses less energy. Then for 1.4, in most homes in the UK, there are many different electrical devices. Explain why people should be encouraged to use energy-efficient electrical devices. Well, this is because more efficient devices waste less energy, which would minimize the electricity demand and reduce the environmental impact from electricity generation. And then moving on to question 2. Figure 2 shows a rock found by a student on a beach. To help identify the type of rock, the student took measurements to determine its density. And then for 2.1, we have our first 6 marker of this paper. Describe a method the student could use to determine the density of the rock. First, you measure the mass of the rock using a balance or a scale. Then part fill a measuring cylinder with water and measure the initial volume. And then you put the rock in the water and measure the final volume. The volume of the rock equals the final volume minus the initial volume. And then I just have my alternative reasoning here. You don't need both reasons, but you could also use a displacement can with water, place the rock in and collect the displaced water in a measuring cylinder to find its volume. And no matter what method you use this final formula of density equals mass over volume to calculate its density. And then the student determined the density of the rock to be 2.55 plus or minus 0.1 grams per centimeter cubed, and we're asked to work out what are the maximum and minimum values for the density of the rock. Well, the maximum density is 2.65 grams per centimeter cubed, and the minimum density is 2.45 grams per centimeter. And then we're given the density of 5 different rocks, and we're asked which 2 types of rock in table 1 could be the type of rock the student had. Well, it could be 2.64 or 4.4 or 2.45. So we need to simply find whatever fits within that range. Well, the maximum chalk could be is 2.35 plus 0.15. So the maximum chalk could be is 2.5, which is greater than the minimum density. And the same with flint. The flint also fits within that range. In fact, like the average for flint fits within that range. So it could either be chalk or flint. The student only took one set of measurements to determine the density of the rock. Explain why taking the measurements more than once may improve the accuracy of the density value, Well, taking measurements more than once allows a mean value to be calculated, which reduces the effect of random errors on the accuracy of the density value. And then for question 3. Oh my goodness, it's the piezo if you're on Instagram Reels. If you're ever on Instagram Reels, this is a big deal. It's the piezoelectric columns in Japan. They're also not in Japan, I have them in my local mall. Anyway, an engineering company has invented pavement tiles that generate electricity as people walk on them. Figure 3 shows somebody walking on the pavement tiles. Use the physics equation sheet to answer 3.1 and 3.2. If you've watched any of my past paper videos, this 2022 onwards is where the physics equation sheets cover all the formula, and you can now use them for all the questions, which is great. However, they still ask you for the equation. So ask which equation links current, potential difference, and power. And that is that P equals V times I, or power equals potential difference times voltage. Potential difference times current. When a person walks on a tile, a potential difference of 40 volts is induced across the tile. The power output of the tile is 4.4 watts. Calculate the current in the tile. Well, we simply use the formula from the formula book. 4.4 equals 40 times I. I equals 4.4 divided by 40. Simply put that into your calculator, you get an answer of 0.11 amps. Very important skill. In fact, it's really the only skill you use in GCSE physics is rearranging formula or just solving equations. Then we are asked to use the physics equation sheet again. Which equation links efficiency, total power input, and useful power output? Well, efficiency equals useful power output over total power input. So, yeah, it's in the formula book. Don't know why I'm going to explain it, but yeah. The tiles are used to power LED lights in the pavement. An LED light has a total power output of 4 watts. The efficiency of the LED light is 0.85. Calculate the useful power output of the LED light. Well, we simply plug the numbers into the formula. 0.85 equals P over 4. P equals 0.85 times 4, and we get an answer of 3.4 watts. Once again, just rearranging equations is the main skill needed here. And then for question 4, a student investigated the insulating properties of different materials. Figure 4 shows some of the equipment used by the student. This is the method used. Wrap insulating material around the can, put a fixed volume of boiling water in the can, place the lid on the top of the can, measure the time taken for the temperature of the water to decrease by a fixed amount, and then we simply repeat steps 1 to 4 using the same thickness of different insulating materials. And then for 4.1, we're asked to identify the independent and dependent variable in this investigation. Well, the independent variable is the thing you change, and the dependent variable is the thing you measure. So the thing you change is the type of insulation, and the thing you measure is the time for temperature to decrease by a fixed amount. And then the student used 2 different types of thermometer to measure the temperature changes. Figure 5 shows a reading on each thermometer, and we've just shown it. What is the resolution of thermometer B? Well, it gives it to the nearest 0.1, gives it to 1 decimal place. So the resolution is 0.1 degrees Celsius. And we're also told thermometer A is more likely to be misread, and give one reason why. Well, the viewing angle affects the measurement, causing a potential parallax error when reading the position of the liquid. So, quick diagram. I'm very good at drawing these diagrams. If you're looking at it from here, your eyes are going to go through there, and it's going to go down a bit. If you're looking at it from, I'm going to do a more drastic example here, you're seeing that, and you're actually seeing the result to be a lot higher than it is. So you need to read it perfectly level to get it accurate. And quite often, especially GCSE students, they don't do that. So it's a lot better to use thermometer B, where you can avoid the risk of parallax error in its entirety. Then for 4.4, For one type of insulating material, the temperature of the water decreased from 85 to 65 degrees Celsius, and the energy transferred from the water was 10.5 kilojoules. And the specific heat capacity of water, as all these questions are, I think one time they even asked you to just a multiple choice, what is the specific heat capacity of water, just because you're expected to know it, is 4,200 joules per kilogram Celsius. I'm asked to calculate the mass of water in the can. Well, firstly, we convert 10.5 kilojoules into joules, and we just get an answer of the energy equaling 10,500 joules. And then we use the formula E equals m times c times delta T, where delta T is the change in temperature. They also have it in words in the formula booklet, but we don't need that. And then it's just 10,500 equals m times 4.2 times 85 minus 65, which is just 20, and we get the mass just rearranging, dividing both sides by this to get the mass. We get the mass equals 10,500 divided by 84,000 to get a mass of 0.125 kilograms. And then table 2 shows the results of two insulating materials. Material X, it takes 450 seconds to decrease by 20 degrees Celsius, and for material Y, it takes 745 seconds to decrease by 20 degrees Celsius. Explain how the results in table 2 can be used to compare the thermal conductivity of the two materials. Well, material X shows the same temperature decrease in a shorter time, meaning it has a higher thermal conductivity because the rate of energy transfer is higher. Moving on to question 5. A student rubbed a plastic rod with a cloth. The rod became negatively charged and the cloth became positively charged. Explain why the cloth became positively charged. Well, electrons were transferred from the cloth to the rod. Electrons are negatively charged, so there are more positive charges than negative charges on the cloth, making it positively charged. And we're then shown the negatively charged rod on a balance, with figure 7 showing how another charged rod being held stationary above the rod on the balance, and the rods do not touch each other, and we're shown how the mass on the balance increases if there's a charged rod being held above it. And explain why the reading on the balance increases. Well, the held rod is negatively charged, and rods with like charges, in this case negative charges, repel each other. This means there is an additional downward force on the balance which increases the mass reading. And we're told that the balance has a zero error, and we're asked to explain why the zero error is not important in this experiment, and we're asked to give the reason why. Well, only the change in the reading has been observed. So the zero error is the same for both readings and cancels out. So if you're measuring the change, let's say there's a zero error of plus 1 gram here and plus 1 gram here, the change is still the same no matter the zero error, just meaning that the zero error cancels out, as I just said. And then we're told a negatively charged rod is held near an earthed conductor. Explain why a spark jumps between the negatively charged rod and the earthed conductor. Well, the large potential difference between the two objects causes negative electrons to move through the air from the rod to the conductor, producing a spark of electricity. Figure 8 shows how electricity is supplied to the consumers by the national grid, and we're asked to explain why transformer X is used in the national grid. Well, transformer X increases the potential difference and decreases the current of the electricity in the transmission cables. A lower current reduces the thermal energy transfer to the surroundings from the cables, which increases the efficiency of power transmission. So basically what it just does is it increases the current, decreases the current, increases the potential difference, which means it loses less energy in the overhead transmission cables, meaning more actual power gets to the consumers. And then we're asked why transformer Y, which is this one, is used in the national grid between the overhead transmission cables and the consumers. And that's because it decreases the potential difference to a safe value for use by consumers. So basically, if the potential difference is too high, it can be dangerous for consumers. So transformer Y brings it down to a safe level, which is why you often see signs outside of like substations and stuff, which is where these transformers are, telling people not to go near it because the potential difference in there is higher, which means it's more dangerous. So you're told not to enter. Then, for 6.3, the town of Hornsdale in Australia has electricity supplied by a huge battery. One day, the battery transferred 3.24 times 10 to the 11 joules of energy to the town. The potential difference of the town's electricity supply is 230 volts. Calculate the charge flow to the town on this day, and we're asked to use the physics equation sheet. Well, we just used the formula that energy equals charge times voltage, divide both sides by 230 to get an answer of a lot of volt, a lot of charge, a lot of coulombs. 1,408,695,652 coulombs, which you could just give it to three significant figures like that, or you could give it in standard form as 1.41 times 10 to the 9 coulombs. Alpha particles, beta particles, and gamma rays are types of radiation. What does an alpha particle consist of? Well, an alpha particle consists of 2 protons and 2 neutrons. And while it's not directly relevant to this question, this means it has an atomic mass of 4 and an atomic number of 2, which is the same as a helium atom, which is used for many equations, such as 7.2, but 7.2, instead of it being alpha decay, it's beta decay. A krypton nucleus decays into rubidium nucleus by emitting a beta particle. Complete the nuclear equation for this decay by writing the missing number in each box. Well, you just use the periodic table to get 65 for krypton and 37 for rubidium, or you can just try and balance it out the bottom, or you could just try and balance it out the bottom and the top. At 85 equals 85 plus 0, and 36 equals 37 minus 1. So you can just try and balance those equations to prevent you using the periodic table. Internal contamination of the human body means radioactive material is inside the human body. Explain how the risk from internal contamination is different to the risk of external radiation by a source of alpha radiation. So, basically, alpha radiation has a low penetrating ability, so when the source is external, it's stopped by the skin and therefore poses low risk. However, when the radioactive material is inside the body, aka internal contamination, the alpha radiation is absorbed directly by living tissue and organs. And since alpha radiation is highly ionizing, internal contamination will cause greater harm to cells, tissues, DNA, and genes, and overall cause a large risk of death. There were a few nasty cases, probably when I was really young, probably when you guys weren't even born yet, of a bunch of assassinations where they slipped alpha sources into people's food, and they're undetectable because the alpha radiation can't penetrate to the outside of the body. So basically, you're just being burned alive from the inside, which isn't very fun, I've heard. Okay. Then for question 8, a student determines the specific latent heat of vaporization of water, with figure 9 showing some of the equipment used. And then we're just given the method they used. They put 50 centimeters cubed of water in a beaker, measured the mass of the beaker and the water, use a heater to boil the water and keep it boiling for 600 seconds, measure the mass of the beaker and water after 600 seconds. So, what measuring instrument should be used to measure the volume of the water? Well, obviously a measuring cylinder. And what is a hazard in the student's investigations? Well, burns isn't actually a hazard, it's a result of a hazard, and these are safety precautions. So the actual hazard is the boiling water. And then the initial mass of the beaker and water was 0.08 kilograms. The final mass of the beaker and water was 0.071 kilograms. The energy transferred by the immersion heater as a whole was 25,200 joules, and we're asked to calculate the specific latent heat of vaporization of water given by the student's data. and we can use the physics spreadsheet. Well, firstly, we have to work out the change in mass, aka the mass of the water that actually changed state, which is 0.009 kilograms. And then we simply use the formula E equals mass times latent heat of fusion, or vaporization in this case, to get 25,200 equals 0.009 times the latent heat of vaporization. The latent heat of vaporization equals 25,200 over 0.009, which gets us an answer of 22.8 million joules per kilogram, or just 2.8 times 10 to the 6 joules per kilogram. You could have also given as 2.8 megajoules per kilogram, or just messed around with the units in those ways, but this is the most simple one. And if you do A-level physics, you'll learn about SI units and SI base units, and this is the SI base unit. Well, not a base unit, this is the SI unit for latent heat vaporization. And if you want to work out how to actually get the unit, well, you're simply dividing the joules by the kilograms, so it's joules per kilogram. And then some thermal energy was transferred to the surroundings while the water was being heated, and we're asked to explain how this affected the student's value for the specific latent heat of vaporization. Well, because some thermal energy was transferred to the surroundings, less energy than the 25,200 was actually transferred to the water. So the student's value of L was too high, because if you go back to this equation, if the mass stays the same, and the actual energy transferred to the water goes down, the latent heat of vaporization would also go down. And some of the water evaporated before its temperature reached 100 degrees Celsius, and we're asked to explain how this affected the student's value. Well, because some water evaporated before reaching 100 degrees Celsius, so the measured change in mass was too high, and this means the student value of L was too low. And if you go back the same, if the measured value of mass was too high, if you decrease the mass, the L would increase, which means the student's value of L is too low. Sort of two questions which are like an inverse of one another. And then moving on to question 9, figure 10 shows a girl doing an experiment to determine her power output by walking to the top of some stairs. The mass of the girl was 60 kilograms, the height of the stairs was 175 centimeters. The girl ran to the top of the stairs in 1.4 seconds, and the gravitational field strength is 9.8 newtons per kilogram, and we'll ask to calculate the power output of the girl using the physics spreadsheet. Now, first things first, power output, you're thinking of energy over time. You have the height, the mass, and the change in height. The main goal here is going to be to find the gravitational potential energy gained and then divide it by 1. So we simply do that. Height equals 1.75 meters, and converting it to meters. The gravitational potential energy is the mass times the gravitational field strength times the height, which gets us an answer of 1029 joules. And then power equals energy over time. 1029 divided by 1.4 gets you an answer of 735. And then for 9.2, the total power output of the girl was greater than the answer to question 0.9. Well, the girl also increases her kinetic energy as well as her gravitational potential energy. So when she gets to the top of the stairs, she's still going to be moving. And also, some energy is wasted in her muscles, transferred as thermal energy to the surroundings. As muscles aren't 100% efficient, not all of it's going to be converted into like gravitational potential energy, and you'll know that if you when you run a bunch or do a bunch of exercise, you overheat. So that is the waste heat energy from the muscles being transferred to surroundings. That is the heat you generate when exercising. Well, a boy took more than 1.4 seconds to run up the same stairs. The power output of the boy was considered to be the same as the power output of the girl. What conclusion can be made about the boy's mass? Well, this is that the boy's mass was greater than the girl's mass, because if power equals energy over time, if the energy is to stay the same, well, if the power output was to stay the same and time is increasing, the energy would also have to increase. And well, gravitational field strength is constant on Earth. The stairs, it's the same stairs, so we know the height's constant. So the only thing that can increase to cause the energy to increase is the mass. And then for question 10, figure 11 shows the student launching a toy airplane. To launch the airplane, the student pulls on the spring, and then releases it. Just before the toy airplane is released, the spring has an extension of 0.12 meters. The mass of the airplane is 0.02 kilograms, and the spring constant is 50 newtons per meter. And we're meant to calculate the maximum speed of the airplane just after its launch. Well, because energy is constant, we know that the energy gained via the spring is going to be equal to its kinetic energy. So what we simply have to do here is obtain the elastic potential energy using the formula 0.5 times k times extension squared, which is 0.5 times 50 times 0.12 squared, getting the spring constant, the extension, and 0.5, just says 0.5 in the formula book, and that gets you an answer of 0.36 joules. And then you simply set the 0.36 joules equal to the kinetic energy. You get 0.36 equals 0.5. You could have probably just cancelled the 0.5. Another way to do this is just set the formulas equal to each other and rearrange, but it is easier just to do it in steps, plugging the numbers in. So 0.36 equals 0.5 times 0.02 times v squared. Rearranging, you get v squared equals 0.36 over 0.5 times 0.02 equals 36. And, well, you square root both sides. V equals plus or minus 6 meters per second. You'll get asked for the speed. Speed is a scalar, not a vector, so can't be negative. So it is 6 meters per second. And you're also asked to give the unit. If you don't know what the unit for speed is, you shouldn't be doing this question. And then, as the plane moves upward through the air, there is a decrease in the kinetic energy of the airplane due to air resistance. You don't have to say that. And we're asked to give one factor that would increase the distance the toy aeroplane travels horizontally before hitting the ground. So while increasing the extension of the spring would increase the distance the toy aeroplane travels horizontally before hitting the ground. So basically, it hits the ground when the kinetic energy is 0 and it stopped moving. Or while it would still have some kinetic energy when it hits the ground. But increasing the extension increases the elastic potential energy, which increases the kinetic energy, which allows it to travel further. And then for question 11, figure 12 shows some hair straighteners, and they contain heating elements. When the hair straighteners reach normal operating temperature, an LED turns on, and we're asked to draw a circuit symbol for an LED in the box. And I just have a small description here, so I can draw it with you guys. It's just a diode, which is this symbol, showing that a current can only flow in one direction. And for the light emitting part, it is just 2 arrows, showing that it is emitting light. And while you could probably draw a better symbol than that, this is acceptable because I am not an artist. I am a science tutor. Sort of looks like the subscribe button. Maybe you should press that. I believe I did that. Anyway, moving on to the next question. Figure 13 shows the circuit diagram for the hair straighteners. Each resistor represents a heating element. The power output for the hair straighteners can be changed by closing different switches. And why do the hair straighteners not turn on when only switch 2 is closed? Well, there's a gap in the circuit because switch 1 needs to be closed to complete the circuit and turn the hair straightener on. How this would usually work in real life is there's like a little settings button here, or a little slider. This is off, this is like power 1, and this is power 2. And as you slide it across, first it closes this, then it closes this, and then it closes this. Well, actually it would be a slider up here for off, and then 1, 2, 3. So as you slide it along, it closes this switch first for power setting 1, then both of these switches for power setting 2, and then all 3 switches for power setting 3. And then for 11.3, the hair straighteners have a maximum power output of 120 watts. The energy transferred to the hair straighteners to reach normal operating temperature is 3.6 kilojoules, or just 3,600 joules, and we're meant to calculate the time taken for the hair straighteners to reach normal operating temperature when operating at maximum power. Use the physics equation sheet. Well, as I said, 3.6 kilojoules is 3,600 joules, and using the formula energy equals power times time, we get the formula of 3,600 equals 120 times t, rearranging to get t equals 30 seconds. And then figure 14 shows the hair straightener with switch 1 closed. Switch 2 and 3 are closed at the same time. Explain what happens to the power output of the power supply. Well, the total resistance of the circuit decreases as more resistors are added in parallel, and that decreases the resistance because the current has more ways to flow. Think of it as like the current is water. The water analogy is very overused for electricity, but it works. So previously you were forcing all the water through like one hole, but now that the water can go through 3 holes, there's less resistance to the water and more water flow, aka current, and an increase in current means the power output of the power supply increases. And the voltage, which is the pushing force, stays the same, even if you have more. Anyway, that's the end of that paper. If you've enjoyed this video, make sure to like and subscribe, and I'll see you next time for more past papers.